Hi all, welcome to the ninth session of Introduction to Big Data. Today, we will try to understand the difference between the traditional and big data approach as well as the different phases in the big data adoption process. Click the bell icon below and subscribe to my channel if you have not subscribed yet so that you will get a notification when I upload my next video. In the traditional approach, the process used to start from the business users. Stakeholders or business used to determine what question to be asked. Then those questions were taken up by the IT, who then structures the data in a way to answer the questions. This was a structured and repeatable analysis. Examples are the monthly sales report, customer surveys, etc. But in the big data approach, there is a major change in this. Here, the IT delivers whatever data they have in a platform which provides the capability for analysis in any which way required. This platform is explored by the business users who frames the different questions that can be asked and answered using the available data. This is an iterative and exploratory analysis. Some examples in this approach are the brand sentiments, product strategy, etc. The major difference between these two approaches from the perspective of data is the usage of data itself. In the traditional approach, the analysis is done on the required data for the question that the team is trying to answer. Whereas in the big data approach, the entire data set that is being collected is taken up and will be analyzed upon to create useful insights out of it. Now let's see a high level data pipeline in big data. All the different types of data, as in the data in motion, data at rest, and data in other various forms are being used up in the big data approach. Data in motion or the streaming data is usually taken up into the real-time analytics platform. Data at rest moves into the information ingestion and operation information zone. All the other data forms are being pulled into the landing, analytics and archive zone, where the real-time data as well as the ingestion data also flows in. All the exploration analytics will be done on the data that is there in the analytics zone as well as the real-time analytics platform. Then there is the outermost layer wherein the analyzed data or the information is being exposed to the end users through different applications like decision management, BI and predictive analytics, and so on. Taking all these into consideration, there are certain scenarios where Hadoop is very good and scenarios where Hadoop wasn't getting fit as well. Let's see that. Hadoop is a good choice when there is a massive amount of data wherein parallel processing is possible, when there are different varieties of data, and when there is commodity hardware in place. But Hadoop was not a good option in the following cases. If there is a requirement for random access process transactions, that is, online transaction processing or OLTP, Hadoop is not a good fit. This is because Hadoop doesn't have the capability for updates, but has only deletes, inserts, or appends. Similarly, if work cannot be parallelized, if there is processing of a lot of small files, intensive calculations with little data, or if there is a requirement for OLAP, which is Online Analytical Processing, or DSS, Decision Support System, Hadoop is not the right choice. Also, if there is a need for low latency data access, Hadoop is not the best choice as Hadoop works on the concept of batch processing. One thing to be noted is, as there has been a lot of development and enhancement over the years, now some of these limitations can be overcome indirectly using different available technologies. This leads us to the most important thing, which is Hadoop is not a replacement of RDBMS because of Hadoop's inability for updates as well as the processing methodology involved is batch processing. This is a major hindrance for OLTP and hence RDBMS is still the best option for online transactions. Hadoop complements RDBMS by helping to manage the data. This takes us to the different phases in the big data adoption process. This was proposed by IBM's John Graham Nosworthy and is called as the 4 E's of data analytics. The first phase is the educate phase, wherein a proper understanding of what big data and analytics mean to your organization and how you define it, how the marketplace in and around your industry and your competition are either applying or not applying analytics for operations is made. The next is the explore, where exploring all the possibilities you can have with big data is done. The third one is engage, where we move from learning to applying what we learned and understood, like having a pilot project running. The last and the final phase is the execute, where the organization starts delivering smarter customer experiences by deploying production level big data projects. With that, we come to the end of this session. Thank you for watching. If the video was informational, do like the video, provide your feedback in the comment section, and share and subscribe to my channel.